done in 7 minutes. All right, 1-4C, notes, verify inverses graphically, okay? There are 2 ways to verify that functions are inverses. Today, we're gonna focus on graphically, and tomorrow we're gonna focus on algebraically, cool? All right, so focusing on graphically. To determine if the following graphs are inverses, there's a couple things. There's the invisible line of y equals x. So this little dash line, that's y equals x, okay? That's my line of reflection. Okay, that's my line of reflection. And it's called y equals x because all the points that make up this line are when y and x are the same. So 1, 1, 0, 0, 2, 2, 3, 3, -1, -1, okay? So first thing you look for in your line of reflection if 2 functions are inverses. So I have function f here, and I have function g here. And I want to know if they are inverses of each other. Clue number 1, do they intersect on the line of reflection? On line of reflection, okay? And do they? Yes, right here, check, okay? Second, are all points the same distance from line of reflection? All points, same distance. A little bit. Same distance. So to check distance, distance means, am I going the same? So here to here, is it the same distance? Why, yes, it is. Do we see that? From here to here. And then here. Uh-oh, went the wrong way. It's gonna be the same distance. Why is it the same distance? Because in geometry, you learn if your Pythagorean theorem, right? If I have the 2 same A and B values, then my C values are the same. So my A and B value here is 3. This is 2. This one is 2. This is 3. So that, what does that mean? My distance has to be the same. Because no matter how I square and add those 2 together, they're still going to equal the same number, right? All right. And then if both of these add up, then guess what? They're inverses. F of x and g of x are inverses. Yay. How do you feel about verifying graphically? 2 steps, right? Do they intersect? Okay. And are all points the same distance from the line of reflection? Cool. All right. Now we're going to do it completely from scratch. Okay. So they want us to verify graphically whether these 2 functions are inverses. So in order to do that, we have to graph them. If you took your notes last week, 1-2D notes, yeah, your 1-2D notes. It reviewed and went over with you how to graph from Algebra 1. Okay. So if we're in point slope form, so we're in point slope, that means we have y equals mx plus b. Agreed? Your b is where you start. Your m tells you where you're going. Make sense? Your b tells you where you're starting, and your m tells you where you're going. Okay? So looking at f of x, what is my b? 2. That means I start at 0, 2. Still with me? This shouldn't sound foreign. Okay. My m is 1/3. That tells me where I'm going. So that's my rise and my run. Because they're both positive, to create my line, I'm going to go up 1 and right 3. And then I'm going to go down 1 and left 3. And that's because they're both positive. Still good. So I start at 0, 2. So I go to 0 and go to 2. And I'm going to follow the directions of where I'm going. So I rise 1 and then right 3. 1, 2, 3. I'm going to rise 1, 1, 2, 3, and go 3 to the right. Rise 1, 3 to the right. And then I'm going to make the rest of my line by doing the opposite. So down 1, 3 to the left, down 1, 3 to the left, down 1 and 3 to the left. All right. So I'm gonna do my best, pretend that this is the world's straightest line that you've ever seen. All right. Okay, so we're gonna do the next one. So I'm gonna pause for a second and let you plot the second line yourself without me walking you through it, just so that you can remember how to do it. Okay. Ready? So your B here was -2. So you should have started at 0, -2. Your M equals 3 over 1. So you're rising 3 and running 1. So I'm at -2. I'm going to go 1, 2, 3 over 1. 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 Okay. And then I'm going to go down. 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. I did. All right. I'm doing my very going. I'm going to make it. All right. That's pretty decent. All right. So now we're going to check. So we're checking, are these inverses? What were our 2 things we looked for as if they are inverses? Do they intersect on the y equals x line? And the answer is no. Womp, womp, womp. And if that doesn't happen, do I have to check any further? No. So here's my y equals x line, and they do not intersect on my y equals x line. Where do they intersect? Right here, not right here, or anywhere else. So the conclusion here is not an inverse. F of x and g of x, not inverses. That just means that they're reciprocals. Yeah, they don't intersect on the green line, the y equals x line. All right. All right, good. Yes. Okay, so now we're going to talk about a very important key concept, one-to-one. Huh? Go back? What were we doing? It says not inverses.
Yeah, no, it's okay. I think it's like turquoise. Okay, Alexis, it is blue. It's a shade of blue.
It's green.
Exact same shade to the right. It's blue, I think.
It's green, but okay.
I'm losing my mind. It's literally a shade of blue. Turquoise. It's like turquoise. No, it's not. See the color right there. It's green. Right there. That's not turquoise.
All right, weird people. Let's continue. Great conversation. Next, we're going to talk about one-to-one functions, okay? A one-to-one function, this should be kind of a recall from Algebra 1, okay? Basically, with a one-to-one function, you do not have any repeating x's nor repeating y's. Your x's do not repeat and your y's do not repeat. Does that ring any bells?
No.
Okay, so again, we have no x repeats and we have no y's repeat. Okay, so graphically what that looks like is that it's going to pass the vertical line test and you're going to pass the horizontal line test. Yes. So what that means is that as I go vertically, I only hit 1 point at a time. And as I go horizontally, I only hit 1 point at a time.
Oh, that's okay.
Now, this is important when you're trying to decide if a graph is going to have an inverse that's a function, okay? Off the back, you'll know it won't if it does not pass the VLT and the HLT, okay? It's a math sandwich, yeah. All right, so here we have, we're gonna graph to show you how this works. So first, we're gonna graph our quadratic, x squared. Okay, so we're gonna graph the x squared. So we're gonna do -3, -2, -1, 0, 1, 2, and 3. So on the quadratic, -3 squared is 9, -2 squared is 4, -1 squared is 1, 0 squared is 0, 1, 4, and 9. Are y'all comfortable with that? I am. Okay, so all we're doing is the quadratic. Quadratic parent function. Nothing new, nothing foreign.
Because that's what you wanted to do.
Yeah, but our graph is only big enough to accommodate up to 9, Alexis. So we didn't have other values because our graph only goes up to 10. I would need 16 in order to go to 4, 25. Ooh, that is pretty, oh, dang, I should have talked. All right, so here's our quadratic. Yes, agreed? All right, looking at this quadratic, does it pass the vertical line test? Yeah. Does it pass the horizontal line test? No, it does not. If I was to go horizontally, I'm going to hit 2 points at every time, right? So it passes VLT, but it fails HLT, okay? It failing HLT lets me know that its outright inverse is not a function, meaning that if I was to find the inverse of this, it wouldn't be a function, okay? I would have to have some restrictions and everything, but it would not be a function. And we're going to graph why that would be the case. So looking here, its inverse, what is the opposite of the quadratic? The square root, right? And when we take the square root, it creates a plus or minus of that. If I was to do the inverse, so instead of graphing -3, 9, what would I be graphing? 9, -3. Instead of graphing, no? Oh, right here, yes. Instead of graphing 4, -2, 2, -2, 4, it will be 4, -2. This would be 1, -1, 0, 0, 1, 1, 4, 2, and 9, 3. Do we see that? So when I graph the inverse, what happens? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, 1, 2, 3. And then
My bad, you were acting. Yeah, I was good. Yeah, well, you saw me answer questions. You saw me ready. I didn't know it.
I'm determined to draw this out. And I did. That's what happens. So, and is that a function? No.
That's me too. Yes. Promise it's 10 minutes.
Oh, sorry. All right, so in conclusion, the quadratic function is not 1-to-1. Therefore, the inverse is a relation, not a function, unless we add restrictions.